It's getting pretty messy out here. It's snowing heavy, and 100th Avenue is backed up all the way to Carlson. Part of Central is closed down completely, too.
Yeah, and it's not going to get any better. By the way, we got a report of icy conditions near the 32nd Street off-ramp. There are already 4 cars in the ditch and 2 wreckers at the scene. Charlie, can you get your truck over there and put some salt down?
Roger, what's the forecast calling for?
Doesn't look good. More sleet, possibly changing to snow later as that cold front begins to move through. I better get another pot of coffee going. Looks like we're going to be in for a long night.
No matter how well you clear your icy streets and highways in winter, no matter how safe you make your roads, you'll never prevent fender benders like these. It's a matter of record. Drivers and winter weather simply don't go together. But you can go a long way towards making roads safer more quickly at lower temperatures and without increasing your budget. And you can accomplish this simply by adding Liquidow liquid calcium chloride to your snow and ice control program. In the presentation you're about to see, you'll learn why rock salt, when used by itself, is a cost-effective de-icer, but with certain limitations. What's more, you'll learn how a small amount of Liquidow calcium chloride added to rock salt helps overcome these limitations. Perhaps most important, the presentation you're about to see will show you how you can combine these two materials without adding to the total cost of your snow and ice control program. In other words, with Liquidow, you can get better de-icing results without higher costs. To start, it's important that you understand how salt works. For example, in order for salt to bore through snow and ice, it must first turn into a solution, or a de-icing brine. But in order to form a brine, the salt must come in direct contact with moisture. Of course, the farther the temperature drops below 32 degrees Fahrenheit, the less free moisture there is for rock salt to form a brine and begin melting snow and ice. In other words, the colder it gets below freezing, the harder it is for rock salt to work. You can see this point illustrated clearly in this chart. For example, at 25 degrees Fahrenheit and in 15 minutes, untreated rock salt can melt almost 10 milliliters of ice. At 20 degrees Fahrenheit in that same time frame, the amount of ice melted by the untreated salt is cut almost in half to just over 5 milliliters. And as the temperature drops lower, the untreated salt's performance progressively worsens until at 0 degrees Fahrenheit, it barely melts 1 milliliter of ice. And what happens when this untreated salt is spread on icy roads? First, you have to contend with material loss because a lot of untreated salt bounces off the road during application. That's because it doesn't have the wetness it needs to stick to the road. In fact, according to results from tests conducted by the state of Michigan, when plain salt was spread on the center one-third of a highway, 30% of it bounced completely off the road. Plus, an additional 24% bounced to the outside two-thirds of the road. This is the result of plain salt's initial bounce and scatter. That means only 46%, or less than half, of the untreated salt that was put on the center third of the road where it could do the most good actually ended up there. As a result of this inefficiency, salt truck drivers tend to respread soon after the first application because they don't see much melting action. And the result? With more spreading runs per road mile per storm, costs go up. This includes material costs, labor costs, and equipment costs. More important, hazardous conditions last longer. The clearing of roads is delayed, and service to suburban and rural residents suffers. Now, let's compare this performance to rock salt wetted with Liquidow liquid calcium chloride. First, consider that Liquidow calcium chloride provides the moisture salt needs to become a brine solution. And second, Liquidow itself is a powerful de-icer. For example, calcium chloride solutions can easily melt snow and ice at temperatures far lower than plain rock salt. Furthermore, since it's already liquid, Liquidow begins undercutting the ice immediately on contact with the pavement. This significantly enhances the entire de-icing action. In short, wetted salt works faster than unwetted salt. Plus, it works more effectively at lower temperatures, all the way down to 0 degrees Fahrenheit, in fact. Here's proof. These shots were taken at 5 degrees Fahrenheit. The untreated rock salt is on the left, treated on the right. Note that after only 6 minutes, the wetted salt has already burrowed more deeply into the ice. After 10 minutes, it appears that the treated salt has penetrated the ice twice as deeply as the untreated salt. And after 30 minutes, we can see that the treated salt has penetrated the ice about 3 times as far as the untreated salt. And how did the treated salt stand up to untreated salt in the Michigan Department of Transportation tests? Let's compare. First, only 4% of the treated salt bounced off the road during application, and only 18% bounced to the outside 2/3 of the road. You can already begin to see the dramatic difference in the numbers between dry salt and wetted salt. In the end, 78% of the wetted salt that was applied to the critical center third of the road stayed there. That's about 170% more than dry salt. Now, consider the implications of everything that's been reviewed thus far. By wetting salt with Liquidow liquid calcium chloride, you get a de-icer that stays on the road, works faster, and works at lower temperatures. But let's face it, adding Liquidow liquid calcium chloride to your snow and ice control program adds to your budget. Or does it? To answer that, it's necessary to balance the anticipated investment in the salt wetting program against the potential savings it can offer. This means that in addition to looking at material and application equipment expenditures, you should also consider the possible cost-saving effects a salt wetting program can have on labor and spreading equipment expenses. To begin, you can examine material costs. At a typical addition rate of 8 to 15 gallons per ton of rock salt, a solution of Liquidow calcium chloride will add around 10 to 15% to the cost of salt, depending on your location, of course. But you'll recall from the Michigan tests, adding liquid calcium chloride to salt reduced bounce and scatter. In fact, the difference between wetted salt and dry salt in those tests was 26%. So as you can see, that alone can recapture the cost of Liquidow and reduce your total costs. What's more, wetted salt melts more ice than plain salt, which of course helps stretch your budget. As proof, tests were conducted recently by an independent laboratory comparing the performance of treated and untreated salt. Results showed that wetted salt melts significantly more ice than untreated rock salt at all temperatures. Specifically, tests showed that over a 1-hour period, wetting rock salt with Liquidow, and I quote, increases melting capacities an average of about 10% at 25 and 15 degrees Fahrenheit and about 25% at 5 degrees Fahrenheit, unquote. Put another way, if these piles represented truckloads of salt, the one on the left untreated, the one on the right wetted with Liquidow, you'd get this much more rock salt free. When you add Liquidow liquid calcium chloride to it. Beyond that, you have savings in labor costs. For example, achieving bare pavement with less de-icer per mile along with fewer spreading runs means road crews can treat more miles with each truckload during each shift. In other words, productivity increases and overtime charges decrease. Finally, you have equipment and fuel costs to consider. For example, reducing the number of spreading runs reduces the number of hours of equipment operation. It also stretches out the time between scheduled and unscheduled maintenance. What's more, fuel costs go down as well. Many of your colleagues around the country have already substantiated these claims too. In numerous reports, they've revealed the kinds of savings that Liquidow made possible for them. And whether they prefer Liquidow mixed with rock salt because it goes to work faster, or because it works at lower temperatures, or because it reduces their salt usage, they all agree on one thing, and that is they definitely prefer wetted salt over unwetted salt. This brings us to the options that are available to you for applying Liquidow liquid calcium chloride to your rock salt. As you may know, there are 3 well-established ways for combining Liquidow calcium chloride and rock salt, each effective and each offering its own advantages. The most common method practiced today is truckload wetting. In this method, a truck loaded with dry rock salt pulls up under an overhead spray bar. The driver leans out of the cab and pushes the timer control button. This activates a pump which sprays the salt with a 32% concentration of Liquidow for a preset length of time. The average application rate is 10 to 12 gallons of liquid calcium chloride per ton of salt. After the salt is wetted with the proper amount of Liquidow, the pump shuts off automatically and the driver pulls away, his truck loaded with the most effective de-icing combination for streets and highways. There are variations on this method too. For example, some prefer to wet each bucketful of salt with Liquidow before it's loaded onto the truck. It helps ensure that all the salt is fully mixed and coated with Liquidow. Others use a conveyor system, spraying liquid calcium chloride on the salt as it travels up a belt to the truck. Whatever the practice, each has 2 important features in common. One, the equipment investment is modest. The basic components include a storage tank, a timer or metering device, a centrifugal pump and piping. The cost of a basic truckload application system with all new components will be in the $8,000 to $10,000 range. Agencies can minimize these costs, however, by using components already on hand. The second feature common to the truckload application system is its use of a 32% concentration of Liquidow applied at a rate of 8 to 15 gallons per ton of salt. The second application option is the truck-mounted or onboard wetting system. This typically consists of a pump and hydraulic motor. They direct the calcium chloride solution to a spray bar unit mounted above the spreader discharge chute. Tanks located alongside the hopper box store the Liquidow. An advantage of this system is it gives the driver full control over when and where he wants to apply wetted salt versus unwetted salt. Many of these onboard systems, which are usually designed by the owners, cost about $2,000 to $5,000 per truck. However, those who are in the market for new equipment can purchase spreader units with liquid application subsystems already incorporated. A schematic drawing of a typical onboard system is available from your Dow representative. As with the truckload system, a 32% calcium chloride solution applied at an average rate of 10 to 12 gallons per ton of salt is recommended. The third application option is stockpile wetting. The major advantage to this is that you need no application equipment at all. Rather, the wetting of the rock salt with Liquidow calcium chloride is a service provided by an authorized Dow Chemical distributor. Normally, stockpile wetting is performed in the late fall or early winter when the temperature of the pile drops to about 30 degrees Fahrenheit. A solution of Liquidow SW 42% calcium chloride, the liquid calcium chloride containing a water-soluble blue dye, is heated to approximately 90 degrees Fahrenheit. It's then injected into the salt pile at approximately 1 to 2 foot intervals using a special probe. The application rate is 8 gallons of Liquidow SW 42% per ton of salt. The heated Liquidow flows through the stockpile, coating the salt with calcium chloride. As the solution is dispersed in the cool stockpile, its temperature drops rapidly. At 69 degrees Fahrenheit, crystallization of the liquid begins to occur. Deeper into the stockpile, crystal growth continues to advance until the stockpile is a mixture of calcium chloride and rock salt. And as long as the stockpile temperature remains below 69 degrees Fahrenheit, runoff of the solution will not occur. Yet the wetted salt remains manageable even in the coldest weather. And you're ready to go with the de-icer combination that improves your snow fighting program significantly. It's important to note that only Liquidow SW42% liquid calcium chloride should be used for stockpile wetting. That's because independent research has confirmed that weaker solutions will run through the stockpile. Here's why. First, you'll recall that a 42% concentration of the liquid calcium chloride crystallizes at 69 degrees Fahrenheit. As long as the wetted stockpile remains below this temperature, a 42% concentration of liquid calcium chloride added at the recommended rate of 8 gallons per ton of salt will be completely stabilized inside the stockpile. Calcium chloride concentrations between 32 and 38%, however, will not crystallize in the stockpile until the pile itself reaches very low temperatures. And until it reaches those temperatures, the chemical would run through the pile. That would leave you with little or no calcium chloride to fight the snow and ice battle. It's important to note, too, that wetted salt stockpiles must be stored on impervious asphalt or concrete slabs. Also, they must be covered to prevent dilution or runoff caused by rain or snow. Finally, users are urged to follow the recommendations for salt storage outlined in the Salt Storage Handbook, suggested by the Salt Institute. This program includes comprehensive guidelines for salt storage and handling and equipment management. Of course, the right wetted salt application method for your agency will be influenced by a number of variables, including the type of equipment available, budget, the severity of your winter, and the size and scope of your snow fighting program. But regardless of your situation, we hope you'll conclude that the methods just described represent a range of options that make a wetted salt program worth further consideration. Just as Mr. Gary Lefton of St. Joseph, Missouri has, or Mr. John Chambers of Monroe County, Indiana, or Mr. Robert St. Clair of Davenport, Iowa. Each of these men and many, many others have tried a wetted salt program and reached a similar conclusion. That is, rock salt wetted with Liquidow calcium chloride melts more ice, it works faster, and it works at lower temperatures than untreated salt. Then again, others have discovered that rock salt wetted with Liquidow helps cut salt usage through reduced bounce and scatter, and through fewer retreatments, that it helps cut labor costs through increased productivity and reduced overtime, and that it helps cut maintenance and fuel costs through reduced equipment usage. But whatever your reason, we're sure that once you try it, you'll agree that rock salt wetted with Liquidow liquid calcium chloride outperforms untreated salt by every cost and performance measure. In fact, why wait any longer to find out if everything that's been reviewed here is true? Simply talk to your Dow representative at the end of this program. He or she will be glad to arrange an application through one of Dow's authorized distributors. And then, and only then, will you have hard, concrete proof that rock salt wetted with Liquidow liquid calcium chloride does indeed work better than untreated rock salt.